I'm hoping we're okay now. Okay, to start it again.
Okay.
Alex, you might want to back up
Back,
2 minutes because we've been
oh,
having intermittent issues. Reese, I don't know whether you have more information.
Yeah, I think LinkedIn is live, but we're having some issues with YouTube, which has never been the case. So yeah, I'm just checking across streams.
We're blaming the infrastructure engineers somewhere. So obviously, they've got the wrong tech stack.
I'm just reloading my streams where I'm watching.
For anyone who can see us, do you want to let us know in the chat just to make sure we're not just talking to ourselves right now?
Yes, please let us know, everyone, and we'll run it back. I'm just going to hide.
Okay, all right. Alex, do you want to go again from like the start of this slide and
sure, yeah.
All right, I'm gonna hide again.
Okay, great. So reversing back a little bit, here are the advantages of open source, which turns out to be some of the cons of closed source. The first is latency. Your time to first token and output is the difference between a laggy product and a fast product, and which feels instantaneous in real time. And with open source, you can really control these knobs. The second is reliability. So as your application scales and gets more traffic, can it serve more users gracefully? Does the first user experience feel the same as the millionth user? And the last is cost. Can you make the unit economics for your app work and make a profit as you're scaling? And so why are we discussing some of the advantages of open source in the first place? It turns out as an AI engineer, or as you're thinking about your own coding tech stack, you should care about some of the same things, the same principles. And because AI adoption is exponential, so your UI, UX, or the projects, the applications, the tools you build with your AI stack should stand out and UI, UX within this competitive market. And open source helps you do that more readily. And at Baseten in 2025, we summarized and learned the same sort of 3 principles. That reliability is actually the new moat. For building in healthcare, for example, customers are asking for 4 to 5 nines in service level agreements, and downtime in mission critical apps like Open Evidence or Bridge directly delays patient care. And speed is the product, as I mentioned. And third, we want to see tools in the market with the right balance of control and abstraction. And now we'll go over 3 of the top, my personal favorites of the open source models for coding specifically today. Before then, we can go over something called Open Router, which is a great place to find what are the most popular models and how they're being used, what apps are using them. So Open Router is this infrastructure layer for routing requests. It provides unified access to 500 plus models, and it has automatic reliability and fallback. And the great thing about Open Router is it has per model, such as a GLM 4.6, different inference provider or infra provider, their metrics. So you can tell their latency, their throughput, their uptime for each model. And the 2 pages that I look at very often, probably multiple times a week, to see how models are doing and what is popular for coding is first this page. So this page sort of shows you the historic trends of the top models around Open Router and gives you a token usage breakdown. So for example, in the week of February 16th, we can see that Minimax M2.5 actually, there were 2.57 trillion tokens processed on this model in aggregate. And then the second page I look at is the LLM leaderboard. The LLM leaderboard shows you the more fine-grained view of how popular the models are and the token usage per model. And so in today's talk, I'll be covering the top 3 models that are actually being used way more than their closed source counterparts, such as Claude Opus, and then GPT-5 is also, I believe, in the top 10, but way below the open source consumption at the moment. The first is Minimax M2.5. This is a really small, fast, and smart model. It's a great default choice for me to spin off parallel agentic tasks. Next, we have GLM5, which is a very smart model, but could be slow due to its high active parameter count and its propensity to reason a lot. And then we also have Kimi K2 thinking, and the latest iteration of Kimi, which is 2.5. It's also a reasoning model, which is the slow, but I would say it's the best multimodal model with joint vision language training, which I'll dive deeper into in a second. So the first is Minimax M2.5. This is really the model that's been released 2 weeks ago that makes running agents economically viable. You can run this model actually on 100 tokens per second for just $1 per hour and 30 cents at 50 tokens per second, which means if you were to run this model for four instances of this model continuously on in production throughout the year, you can run these instances for a mere budget of 10K, which makes it 10 to 20x cheaper than Opus, Gemini 3 Pro, and GPT-5. But the cheap is not alone the story. The model is also more efficient. So the latest iteration of M2.5 actually consumes a lot less tokens compared to M2. And when you pair the token efficiency of this model with its frontier performance, you really get a multiplicative effect on speed and cost. And the main driver behind this model is an RL innovation. So the team developed a per token process reward via an updated algorithm. So instead of giving every token on the RL trajectory at the same undifferentiated final reward, each token position gets a separate reward for both speed and quality. And so this solves the credit assignment problem in long agent trajectories. So in other words, the model can learn that a good call at step 5 was valuable, even if the final output wasn't arrived at step 50. And the team also focused on real-world productivity. So Minimax was trained on senior professionals in finance, law, and social sciences. So M2.5 can produce complex artifacts like financial models and research reports. So this is bridging the gap between just for coding, but also gaining real-world reasoning and knowledge around different industries to make the coding more effective. And so it generates not just raw text blocks. And so the bottom line for your stack as an AI engineer is it's great for parallel coding and agentic tool use. It lets you explore many pathways at a fraction of the closed source costs and very fast. We hear a lot these days about running agents when you go to sleep, spinning up like 5 threads, 10 threads of agents. And this is the model I would pick to make that viable, of spinning multiple threads of agents in the background. The second model is GLM5. GLM5 scales increases the number of parameter almost double from the previous iteration, and it also increases the pre-training data token size. It also integrates the DeepSeek sparse attention mechanism, which significantly reduces deployment costs while preserving long context capacity. And the funny fact about this model is it it did very well on this benchmark called Vending Bench 2, which measures long-term operational capability. Essentially, it's a test that requires the model to simulate running a vending machine business for over a year horizon. And GLM5 actually finishes with a final account balance of 4.44K, approaching the Claude Opus 4.5 level. And lastly, another interesting fact is GLM5 achieves the lowest hallucination level amongst models tested on artificial analysis, which is another benchmark. And so it's very good at not giving an answer at all when it doesn't have the right information versus making up facts. And lastly, I'm very excited about this one called Kimi K2. So Kimi K2 thinking is the earlier iteration that was presented last year. It's the world's first 1 trillion parameter model. It's the leader on 2 benchmarks by huge margin compared to other closed source models. And the thinking version can execute 200 to 300 continuous tool calls, which makes it great at stay on task after planning. And it follows the traditional mixture of expert architecture introduced by DeepSeek. And one big change to Kimi that has sort of redefined how reasoning works in models is they introduced this concept called interleaved thinking or reasoning. So essentially, the model alternates between thinking and tool use compared to chain of thought, where all the reasoning is upfront and then an answer is outputted. Kimi K2 thinking mimics humans more closely. The model reflects after taking actions such as tool calls and then adjusts its future tasks dynamically. Through this, it's able to maintain coherence and solve complex problems by breaking down bigger problems into subtasks and adapt its direction through continuous feedback. And the way they're able to do this is establish a great training pipeline that I think we will see more often in other model pre-training. Essentially, they gathered 3K real tools from GitHub and generated 20K synthetic tools. And they simulated these multi-turn usage scenarios with these synthetic agents and then filtered these trajectories and used that as additional training data, which makes it very good at agentic coding and tool use. And in the latest release of Kimi that happened, just last month, they introduced something that improves reasoning over images and videos, which lowers the barrier to video to code or image to code generation and visual debugging. And here's a demo of the original video that was inputted into Kimi and Kimi's output of a website. So as we think about agents operating in the real world internet and using vision inputs, Kimi K2.5's large scale visual text joint pre-training is purpose built for this, which boosts cross-modal reasoning. Its proven performance is great for challenging tasks like cloning dynamic front-end websites directly from video of consuming and navigating the web. A great fact to know about Kimi K2.5 is that it's a state-of-the-art model on the design arena benchmark, outperforming all of the closed source models, which underscores its exceptional ability in design-centric visual reasoning. And before I go into my favorite developer workflows with 3 of these top open source models, I just want to pause for questions from Richie. If we have any audience questions, we can take.
For anyone in the audience, if you've got any questions, then please do ask them in the chat. We can go to them later. Actually, I do have a question for you. So it seems like when you're building with AI, quite often you're going to want to use several different models for different use cases. Is that a common thing? Like, how do you divide up which models you use for different tasks, like within different parts of the same AI product?
Yeah, I think it's a lot of trial and error and personal preference in terms of the workflow. I think the primary division I sort models between is like its speed and intelligence. You can sort of plot it around those two axes. And so I would let something that is decently intelligent and fast to do most of the tasks, and they tend to be cheaper as well. And then reserve some of the planning or like higher order tasks, especially tricky bugs, for example, to the smartest models possible. And then I'll sort of just wait patiently on their outputs.
Okay, so I guess you want like the smallest, sort of fastest model that actually solves the problem, like well. So I guess a lot of the time you're gonna be using like these simpler models, and then like for the really tricky tasks, you're outsourcing to the like the I guess frontier cutting edge models. Is that about right?
Yes. Yeah. Correct.
Okay. And when you were doing your research for this, like how do you find out which are the best models? Because there's hundreds of them now.
Yeah, I think definitely reading on what I recommended, like scanning Open Router, which has these leaderboard about usage data and people's preferences. You can also see the top consumption apps on these leaderboards, which means like, hey, if app in this domain I'm interested in is using this model a lot in particular, it's probably good at tasks within that domain. Also, just I think trial and error with your own production data and your own like engineering tasks. You know, if you're a AI or like you're an engineer trying to use more AI tools, everyone's code base looks different and it operate in different domains. So yeah, I think it's trial and error there.
Okay. I mean, I like the idea of getting data on like what other people are using for similar tasks, and that's going to be a good starting point. But yeah, you've got to try it and see if it works on your own use cases, and just see what happens. All right, nice. Okay, let's
We
carry
can
on. We'll
resume.
do
Yeah,
more
sounds
questions at
good.
the end. Right.
And then this is the most exciting part of the my presentation, which is my personal workflows as developer and the different harnesses that you can use around coding today. So the first is very popular, the Claude Code CLI. So a way I like to use Claude Code is actually a hacky workflow. So you can actually reroute the base API URL and authentication to point to an open source provider of choice, such as Baseten. And then so this lets you maintain the familiar Claude interface, but run it at a much cheaper and faster rate with a similar level of intelligence. And so here's a quick demo for that. So what we have here is we're using LiteLLM, which is a similar gateway to OpenRouter, as a proxy to route all Claude Code requests to model APIs with options like Kimi-K2 and GLM5. And for GLM 4.6, a previous version, at base 10, we're actually able to increase the throughput by up to 167% and reduce costs by 5 to 7x with our inference stack. And so a question you might ask now is, instead of hacking these existing CLIs and interfaces, what if there was a way to build an open source native IDE that really takes advantage of the three models I touched on? And I think the question ultimately boils down to the harness. And so each tool manages the context, decides when to call the model, the system prompt, how to parse and displace the results all very differently. And the same model under the hood could feel different across workflows. So now I'd love to give you some options to consider for these workflows. So the first is Vercel AI SDK. Vercel is a platform to build web applications. To build web applications, modern JavaScript applications. So you can import different models and providers within the Vercel AI SDK v5, and they have built-in capabilities across streaming, async, and batch requests, and the patterns can help you build these robust AI web apps very quickly. The second example of a workflow here is LaneChain. So LaneChain recently launched a product called Agent Builder, and this is essentially for knowledge workers that are non-technical or citizen developers. It allows you to use an open source model in the backend to power the agent, and there's no coding involved, and all you do is describe the task you want the agent to execute frequently, and the UI in LaneChain will actually guide you on how to create such an agent with questions, multiple choice questions, as you can see here. And once you answer these multiple choice questions, such as, I want to build a meal planning agent, and then it asks you what types of meal plans, your dietary preferences, and how often you want meal plans, it's able to build a completely functional agent for your specific use case within seconds. And yeah. Another option is Klein. So Klein is a tool, an IDE with over 5 million installs. And the nice thing about Klein is you can bring your own API key, and the interface is sorted into both planning and act mode. The team has sort of created a list of pre-written system prompts. So the context management is automatically built in. It automatically handles file reading, editing, and command line execution, and it manages your state or conversational history within the workspace. And we also have to cover the fastest growing project in terms of stars on GitHub, which has taken the internet by storm recently, called OpenClaw. So OpenClaw is your own Jarvis. So you get started by choosing a model and a list of apps to be connected. And people on the internet have built crazy workflows with this model, from booking restaurant reservations through issuing a command to a voice calling agent, to creating apps while just texting it through WhatsApp on your phone. And when you swap in these open source models to power OpenClaw, the result is not only 8x cheaper costs in tokens, but also 4.5x faster in output. And lastly, there's Cursor. This is my go-to setup as an AI engineer. So I like to organize Cursor in two parts. The first is using their latest composer model. I find it to be awesome for faster, non-complex queries. And I also have the Claude Code tab open in Cursor. And this is for project planning and for harder tasks that I need to be done absolutely correctly with higher confidence and not worried as much about time. So here in Claude Code, I just used the best version of Opus, which is 4.6. And in the final section of the presentation, at Baseten, we power a lot of these leading coding agents like Klein, Zed, and Cursor. So I'd love to dive briefly into how we optimize these models for inference. So let's consider the use case of building a great auto-completion tool. So for auto-completion, the key metric is how fast the first tokens appear. So users usually notice any delay over 100 to 200 milliseconds. So unlike chat interfaces where people are expected to wait, auto-completion needs to feel instantaneous or it breaks the developer's flow. This is why latency optimization matters so much more than pure model quality in the use case. The second thing we care about for autocomplete is the optimization for long prefill short decode. So auto-completion has a unique pattern. You're processing a lot of context, the entire file or multiple files, but only generating a short snippet of completion. This is the exact opposite of chat, where you have multiple short prompts and long responses or files being generated. So the architecture serving this needs to be optimized for this asymmetric pattern. Lastly is its need to keep up with the developer's workflow. So the developers don't want to slow down for their tools, so the tools need to keep up with them. If the suggestions are slower than their typing speed, it becomes useless or even annoying. So the system needs to handle rapid context changes around the code base as the developer navigates around it, and switch files and make these edits quickly. So how are we able to optimize the best version of autocomplete? So the first thing we did is we built and used KV cache. So the key value cache is used. So instead of passing in the entire context of the code base each time, the decode phase could be faster if we've seen similar tokens in the past. The second technique is KV-aware routing, which means users on the same conversation thread will be able to be routed to the same replica on the inference server where the cache is already built. And lastly, we used an n-gram dictionary, which is a speculative decoding technique. So the dictionary matches prefixes to likely suffixes and is really awesome for constrained languages like code. So the dictionary contains common sequences from the input text, and which is first constructed during the prefill. And during decode, the generated token is then fed into the dictionary, and any available suffixes is selected as draft tokens. In the next forward pass, the target model then verifies these draft tokens that are generated way faster than regular tokens as normal, and thus we're able to increase the latency and throughput. And the results is once we rolled it out for a customer, we're actually able to process 2x more tokens during their peak traffic time and greatly reduce their response time. So to wrap up, here are some general takeaways. So if you're an AI engineer and you're just using Claude Code or Codex, you're definitely missing out. Open source models have been closing and have closed the gap. Developers have built a rich ecosystem of tooling around open source to support this. And the best thing is to experiment and not limit yourself. And if you care about building delightful UX with AI, you should care about these three pillars: performance, reliability, and control. So apart from these general takeaways, here are some actionable steps you can improve as an individual contributor or engineer. So how I like to think now with these agentic tools is delegate and review code like a staff engineer. You want to ideally develop your own taste of models and harnesses. So try things like Klein, Cursor, Claude Code, OpenClaw, LangChain, and then let them do things for you to develop that own taste and intuition. And these models have reached a point where they're so capable given the right information. So the golden question I like to ask myself is there sufficient context for the agent to figure out what the answer is? And this may solve most of your problems. And because when these models are so capable, sometimes it's a matter of not possessing the right information versus not being able to do the task. And yeah, that's it. Thank you so much for listening.
All right, wonderful. Thank you so much, Alex. So from the audience, we've got plenty of time for your questions. So please do ask them in chat. Before that, I've got some questions for you. So first half, we were talking about like which is the best model, and the second half was all about like, well, what's the surrounding sort of tooling ecosystem? So just make sure I've understood like all the categories of things you need. So you talked about having like an ID, whether it's Cursor or something else, and then there was like a development framework, so things like LangChain, and then you obviously need an inference platform like Baseten, and then what else? What are the other categories you need just to make sure I've understood all the different components?
Yeah, so my talk was sort of divided into three parts. The first part was arguing why you should reach for these open source models and some of their advantages over closed source. The second part is the top three state-of-the-art trending open source models as of like today. And the last part is sort of the harnesses or the IDEs you can use to through like you can use these models through. So when you choose something like Cursor, you choose something like Klein or OpenClaw, you need a model to be powering all the like agentic tasks. So yeah, that part is sort of like the third decision point. Yeah.
Okay, and I remember like maybe a year or two ago, there was like a lot of discussion about like which vector database you need and all this sort of like if you're doing RAG systems. Like, do you need to care about all these other sort of parts of the stack as well?
Yeah, I think I'm pretty. I think the coverage of this talk, I tried to just concentrate on the coding use case and how I think about like becoming a better engineer with these AI tools. But yeah, there's definitely needs for like robust monitoring tools like weights and biases for if you're training an ML model, like if you're a specific like ML engineer, if you're building embeddings and trying to reduce hallucination and augment the data in some way, then yeah, I think that's a whole different talk on like what are the best vector databases and how you choose between them, right? But I think a lot of the things we think about when we choose the right coding models generally is like some of the same considerations you can take to evaluate vector databases, for example, like what's the batch size, right? Like what's the performance factors? Can you should you optimize for latency or throughput? Like, so a lot of those decisions we navigate when we think about like how we optimize the best coding models too.
Absolutely. So you mentioned like latency versus throughput. This is an important distinction. So just want to talk about like when do you care about latency, when do you care about throughput, and maybe go back to what the definitions are just to remind everyone.
Yeah, so latency is like the key metric to measure usually in the LLM setting is time to first token. So that's how responsive the application feels, like how the time between you asking the model a question versus the first token that gets back to you. And it should be, as low as possible.
All right. So with these reasoning models, sometimes they take a minute or two to think of a response. That's going to be a terrible experience for a chat.
Correct. Yeah, so that's why we talked about techniques at the end there, like KV cache reuse, KV aware routing. So with a lot of these optimizations, you can shorten the time frame a lot if you're on the same conversation thread. And then there's ways to do that on the inference level. There's also ways of just like choosing a smaller model, right? Like sometimes you don't need to go to like Opus 4.6 for everything. So if you care about the speed, like I think a lot of these open source models are like very good and sufficient, more than sufficient for the task.
That's interesting. So actually, with the AI native courses we have, we use the tiniest model. You get a custom welcome message like "Hello user," whatever, and that's like the smallest model possible because it's like that's going to be the thing that generates fastest because that's the first thing that happens, and you want that to be an instantaneous response. You're doing some harder things. You need fancier models, but I like the idea of like start with the smallest thing to get like that first token out, and then worry about other stuff later.
Yeah, definitely. And then I can go over like throughput very quickly as well. That's also, it's usually just navigating between these two trade-offs. And then the throughput trade-off is like how much data at a given. And so this is more of a factor when you're thinking about scaling. So you have lots of customers hitting your endpoint or lots of people using your application. You want to process, a lot of tokens at the same time. And how do you balance that load? How do you push all the load through? How do you make sure everyone's happy? I think that's something you consider more as you scale. But as an individual like developer, I think people care about latency more just from like a usage perspective.
Okay, yeah. So I guess latency is a very important part of user experience, just making sure things go fast. But at some point, you have to scale stuff, make sure you're processing enough tokens.
Yes. Yeah.
Okay. So you also mentioned a lot of the focus is about becoming a better AI engineer, a better developer. Do you have any tips like beyond the tech stack for this? Like, how do you go about working with all these new tools to be effective?
Yeah, I think I covered a little bit at the end. I think it's a lot of like talking to other smart, talented engineers, and you can't really just talk about it. You really need to use it yourself to see if it benefits you. Um, and yeah, it really depends on what projects you're working on, what domain you're working on. And yeah, so my process has been like talk to really smart people, like try to consume high signal information from like Twitter or from these like benchmarks, where you can tell like clearly whether a model is working, and then like play around with it a lot in my workflow, and giving them a chance. Like I think a lot of the harnesses, like it does take time for you to see if you're using it correctly. So I would also be patient here and not like abandon into it just because it's not working for the first 5 minutes. Yeah.
Patience is always the tricky part. It's just want it to work and be done. But yeah, I do like the. Everyone's just kind of trying to figure this out between them on what's going on. So yeah, learning from other people, like sharing stories of what works, what doesn't work. That's an incredibly important part of the process. But also, yeah, get hands on and trying stuff is always the best way to learn. All right, let's go to some audience questions. So a nice one from Charles here. So Charles says, can use these tools for document control, aligning metadata, doc approval, and ensuring security feature align. So basically, like beyond just the writing code, there's a whole set of other tasks around software engineering. Talk me through like, is the tool stack or is the tech stack the same here, or do you need different tools?
What is document? Could you pop up the question?
Document control.
What is document? Like OCR?
I think this is probably about like for your chatbots that do knowledge retrieval, maybe. So it's like what documents you put in there and how do you manage what's up to date and all that sort of stuff.
Oh yeah, I think yes, all the open source models I think can be used for document control in this setting where like, you know, obviously they're not like vector databases, so I recommend using some sort of vector database at the backend to index all of these documents first, but they can be very good like chat response agents on your that lives on your website that retrieves from these documents.
Yeah, you know, so all this stuff about like controlling what documents go, like basically what data goes into your AI. This is actually a very good segue because for the next 2 weeks, like so from next week and the following week, we've got a 2-week series on building trust in AI. There's gonna be a lot of stuff around governing the data that goes into your AI features. So I think Reese can find us a link for you to sign up for that one. So yeah, we've got like 7 different webinars all about like how do you manage all this stuff. So please do come back for those. Oh, on screen as well. Wonderful. All right. In the meantime, next question from an anonymous LinkedIn user. Is there a bigger security risk when using open source models?
I think the argument we usually say at Baseten to folks is like, you know, there's a lot of security risk to closed source models as well. I just want to say, like, you know, you're sending your data to OpenAI or Anthropic and these providers, and you don't know how they're storing it or where that's going at the end of the day. So you are putting a lot of trust in them with open source models because the weights are like frozen in a sense after they're trained. And you want to, you know, serve that model in production on a specific like setting, like you want to host it yourself. You have full control over that open source model, and like, you know, where that's what's happening there. So I'd urge you to think about like the transparency aspect and the control aspect of like your users' data when you're thinking about the closed versus open decision.
Absolutely. So when you like for the really high security stuff, you want to be like in control of your own tech stack. I guess the idea of sovereign AI.
Exactly. You can you can download the weights to open source models. You can host on your own like VPC, where you can like, if that's, you know, you can also host on your own hardware if you're really hardcore. So that's an option there for open source, but not for closed source at all.
Absolutely. So we've got one more question here from the Spiridalytics. Is an interesting name. So is there a roadmap or something of the kind? So a 12-month roadmap for analytics in the website, which not sure what context website. You mean on DataCamp? Yes, we can. Let me try and dig out a link for you, or let me point Reese in that direction. I don't know whether there's another question around like maybe do you want
I'm
to talk
happy
about
to
what's
share the
going on
slides
in there?
if folks are interested after.
Yeah, absolutely.
And try out all the tools I mentioned.
I guess related to that, I mean, so the reason this talk happened is that 3 months ago you gave a very similar talk. We met at the AI summit in New York. And a lot's changed in the last 3 months. You were going to give the same talk, and I feel like half of that was different. So, talk me through, how do you go about keeping up with all these like trends? Like the tech's moving so fast. How do you keep your tech stack up to date?
Yeah, I think alluded to that a little bit. I'll add on to my previous answer of like talking to smart people, consuming from the right sources of information, like looking on Twitter, looking at these benchmarks, reading abstracts or reports on the open source models and their architectures and what they can do well, what they can't do well, playing around it yourself. I think those are the first steps. The other is at Baseten, we work with a lot of customers that are building at the frontier. We work with like Cursor for code generation. We power a lot of Cursor's workload. We have like Notion, Clay, so Abridge, Open Evidence. So when we work with these customers have intimate knowledge of like what a good user experience is because they talk to their customers every day as well. So we're able to like understand, hey, like we want to really try out this new Kimi K2 model. Hey, like we really want to try out this Minimax M2.5 because it's faster and smaller, and we want to try like running multiple background agent tasks with it. So we get a lot of these like insights by hearing what these applications want downstream. So that's been like super helpful as well.
No, I love the idea, like the people building stuff, they're speaking to a lot of their customers. They know kind of what the customers want, but then like it's trying to make sure that the engineering matches the customer's requirements rather than the other way around, rather than like, oh, we're just playing around with a new cool model and then see if the customers like it. So it seems like there's an important ordering there.
Yeah, and I think a thing to add is like it's so costly for you as a business, like if you're building an AI app, to miss like a really great model, right? Like the cost of not using open source model that could be potentially 10x cheaper than Opus, but around the same level of intelligence is just a huge cost for you as a business that you're like very incentivized to try out all the latest stuff and see what works, see if it works well. And yeah, that's
okay. Yeah, it does seem like you might need to swap the models fairly frequently then. So do you have any tips for like how you go about building stuff in a way that allows you to do that?
Yes, I would say if you're building an AI application, you're building a reg system, you're building a customer support chat, you're building anything, and you're using one of these like closed sourced or open source models, you should adhere to like specific patterns that are recommended. Like there's the OpenAI compatible format for completion and chat completion. And there's also like the Anthropic compatible format. So if you manage your code in a way that adheres to like the format that like, open source providers such as like Baseten or Anthropic OpenAI adheres to, you should be okay to like just, it's as simple as like swapping API URL when a new model comes out. There is a little bit, I will say there's a little bit of massaging that you may have to do due to like the output format of these models. So as we're approaching like a new type of model that really likes to reason, that hasn't, like when I gave this talk, around November, that was like the beginning of this trend. But now we're really getting to these like reasoner models. Sometimes they like to do a lot of like interleave thinking, and there's some complexity around tool calling. So that's just on the consumption end. As you're building the application, you have to be very careful about how you're like parsing the outputs.
Okay, yeah. So I love that. In theory, it's just like change the URL and then you've got a different model. But in practice, it's like, I guess you've got to make sure that the output format is the same. There's probably a ton of testing involved. So I guess that's the hard part, right?
Yeah, we do this internally at Baseten as well. We try to deploy like open source models in different settings because people have different like performance requirements. They have different like throughput latency requirements around their workload. So you want to find the best like configuration for each model. So that takes a ton of like experimentation as well. And then also just like writing good system prompts or like iterating on that prompt if it's not one shot. So there's a lot that goes into like making each new model work well for your app. And so, yeah, to start, it's as easy as swapping the URL, but in practice, you really have to see if it works for your production data.
Okay. I mean, do you find that you have to have like, is there a big difference in like the system prompts you need to provide from one model to the next?
Not particularly, but I think different domains varies.
Okay. Yes. All right.
Yeah.
So in theory it works, but maybe there's a bit of
case by case. Yeah.
All right. Just to follow up on the previous question. So there was a question from the Spirit Analytics about roadmap. There's now a link to the DataCamp content roadmap in the chat if you want that. And then we've got 2 minutes. So one final question, which I think should be fairly quick. So Noza's asking, can I trust open source models to assist me during my PhD? I guess it depends what the PhD is on and what you're trying to use it for. But Alex, do you want to take a punt at this?
Yeah, I think it's like highly context dependent. I think if you are using open source models to assist you in like tasks like writing or editing your work, I do have to say like Kimi K2 series is actually like very good at writing like fiction and like creative writing specifically. It's noted for its like great creative writing skills. So I definitely like give that a go. But in terms of if this is like a CS related PhD and you're looking to like, benchmark models or look how they're performing the wild compared to closed source, I think that's definitely like should be considered.
Yeah, probably don't just ask the model to write your entire PhD thesis for you. Like there's gonna be a bit of a little bit of a human in the loop there for your own thesis. Play. I guess the advice is the same as we were saying all day. Is like play around with stuff, try it, see if it works or not. And if not,
right, give it the right context. I think is the most important part. And a lot of it is like, you're not giving it enough information or the right information. It doesn't have access to certain files or certain tools, so it's not going to be able to do the task. But once you give it those things it needs, it's very capable.
Fantastic. All right. With that, we are at time. So thank you so much, Alex. That was a great session. And yeah, I think lots of new models to play with, lots of new tools to play with for now. And probably we'll have to do this again in 3 months once all the latest models changed.
Yeah, the field will look very different in another 3 months. So.
Absolutely. Wonderful. All right. Thank you to everyone in the audience who asked a question. Thank you to everyone who showed up today. Please do come back for the Building Trust in AI session. It's going to be it's important stuff, having trustworthy AI. So please do come back for that. All right. See you all again soon.